Balloon 2-1 Hot air balloon design, system, and theory. Today, we delve into the rich tapestry of hot air balloons, a journey through their design intricacies, the systems orchestrating their flight, and the underlying theories that allow them to grace our skies. Historical research. Our expedition begins in 1783, a pivotal year when the Montgolfier brothers of France unveiled the first hot air balloon, inaugurating human flight. Pilatre de Rosier and the Marquis d'Arlens, the intrepid pioneers, embarked on a 23-minute, 5.5-mile Odyssey that marked the dawn of aerial conquest. Noteworthy, however, are whispers of earlier Chinese exploits with manned kites and potential hot air balloons dating back 2 millennia. A mere 10 days later, Professor Jacques Charles scripted history with the first gas balloon flight, utilizing hydrogen. Thus, the duet of hot air and gas balloons was born in the same year. The ballooning renaissance. Gas ballooning found favor among the affluent, transforming into a sport in Europe and the United States. Crowds gathered at ballooning events, where admission charges helped finance these ventures. The daredevils of the skies emerged, epitomized by André Garnerin's invention of the parachute in 1797, a hallmark contribution to flight. Figure 2-1. Model of the Montgolfier brothers balloon witnessed the historic visualization of the Montgolfier brothers balloon, a symbol of mankind's first foray into the skies. As the 20th century dawned, smoke balloons became a staple at county fairs, featuring riders on trapezes ascending to captivating heights. Balloons also found utility in military endeavors, from Napoleon's anchored observation balloons to their role in the American Civil War and World War I for artillery spotting. Military legacy and modern renaissance. The military's reliance on balloons waned with the ascent of airplanes in World War II, but the mid-20th century witnessed the birth of modern hot air ballooning. A project by the General Mills Company in the 1950s, intended for military purposes but never utilized, laid the groundwork for the contemporary hot air balloon. With the fusion of modern materials and technology, hot air ballooning has blossomed into a sport that beckons enthusiasts worldwide. Join us as we unravel the captivating dynamics of hot air balloon design, systems, and the theories that have fueled their ascent through the pages of history. Unveiling the physics of balloon flight. Welcome to the ethereal realm of balloon flight, a simple yet captivating dance with the fundamental principles of fluid dynamics. At its essence, a balloon is a delicate ensemble of a fabric envelope and a gas lighter than the surrounding air, creating a whimsical vessel that ascends with grace. Balloon varieties. Our journey into the physics of flight distinguishes between two primary balloon types, hot air and gas. However, the vast sky accommodates other unique balloons, such as the Rosier balloon, a hybrid marvel blending heated and unheated lifting gases for record-setting odysseys. A newcomer, the solar balloon, harnesses the sun's radiant energy to defy gravity. For our explorations, our focus remains on the enchanting realm of hot air balloons. The essence of buoyancy. Central to the physics of balloon flight lies the principle of buoyancy, a force born from fluid dynamics. Imagine the air enveloping the balloon as a fluid, and buoyancy becomes the invisible force that propels our vessel upward. In this aerial ballet, buoyancy is the uplifting force exerted on an object submerged in a fluid, be it a liquid or gas. It's the dance of pressure differences creating an upward force equal to the weight of the displaced fluid. In simpler terms, it's the secret behind making an object appear lighter or even airborne. Creating buoyancy. To induce buoyancy, the air within the balloon's envelope undergoes a mesmerizing transformation. It is heated, expanding and becoming less dense. Witness the balletic rise of the balloon. As the interior air lightens, surpassing the weight of the surrounding ambient air, our balloon takes flight, seeking equilibrium where internal and external air densities align. The envelope, akin to a celestial chariot, merely cradles the heated air mass, ascending until lift triumphs over the balloon's weight. Navigating the heavens. The pace of ascent is dictated by the temperature delta between the interior and ambient air, with heat escaping through fabric, seams, and deflation ports. Yet, the journey requires sustenance, fuel to stoke the heat. Only the finest fabrics, nearing airtight perfection, endure, as age and color affect heat retention. Dark hues, under the sun's embrace, might even absorb warmth. Adjusting altitude. As we soar through the heavens, the internal temperature dictates our altitude. A rise in temperature elevates us, ushering in more lift. Conversely, a descent beckons as the air cools. Ingenious vents serve as conduits for controlled cooling, a symphony of temperature adjustments shaping our celestial trajectory. balancing the ballet. Wait, an unseen partner in this dance, waltzes with momentum through the skies. A hot air balloon, a graceful behemoth, hosts not just passengers but an entire ensemble of air mass, components, equipment, and the crew. The intricate interplay of these elements defines our response to the pilot's guiding hand, reminding us that in this airborne ballet, changes unfold with deliberate grace. As we revel in the marvels of buoyancy and fluid dynamics, let us recognize the delicate choreography that propels these celestial dancers, the hot air balloons, across the vast expanse of the heavens. Decoding the anatomy of a hot air balloon. Embark on an enlightening exploration as we unravel the intricate components that compose the poetic dance of a hot air balloon. A ballet of three main characters, the envelope, heater system, and basket, orchestrated to defy gravity and soar through the celestial stage. The enchanting ensemble, the envelope. Our prima donna, the envelope, manifests in lightweight yet robust fabrics, rippled nylon or the resilient dacron. Fashioned from panels sewn into vertical gores, this teardrop-shaped masterpiece is a marvel of engineering. Structural load tapes, both horizontal and vertical, lend strength to the gores, converging at the top center into a load ring. Galvanized, stainless steel, or Kevlar-registered cables elegantly transfer the basket's loads, their silent dance supporting the ballet of flight. The nylon skirt, akin to a protective cloak, bears a special fire-resistant material, shielding the balloon from the enchanting flames within. Witness the balletic deflation port atop the envelope, adorned with a deflation panel, aptly named the parachute top, spring top, or top cap. In the choreography of controlled ascent and descent, the parachute valve gently exhales the warmth, ensuring a ballet of graceful movements through the heavens. Turning vents, akin to pirouettes in mid-air, guide the balloon's pirouette, aligning the basket for landing or, in the realm of commercial balloons, unveiling the balloon's logo to an enraptured crowd. Special shape balloons. Enter the world of special shape balloons, the avant-garde artists of the sky. Departing from the traditional teardrop, these engineering marvels mimic cans, sports balls, cartoon characters, or even cars. Some flaunt appendages, additional pieces adorning the envelope to sculpt unique renditions. While sharing the same ethereal balletic flight as their teardrop counterparts, special shape balloons bring a nuanced choreography. Appendages, though adding weight and influencing rotations during climbs and descents, breathe life into these unconventional dancers. Engineering prowess ensures flight characteristics remain impeccable, granting them standard airworthiness certificates. Diverging paths. Yet, within this celestial ballet, a divergence beckons. Special shape balloons, when imported, might wield an experimental airworthiness certificate. A caveat echoes. No flight for compensation or higher and restrictions on venturing over congested areas. For pilots steering these experimental marvels, meticulous coordination with flight service district offices becomes a prelude to their celestial performance. Thermal airships. A mythical creature within our aeronautical tapestry, the thermal airship fuses the buoyancy of a hot air balloon with the navigational finesse of an airship. A rarity, numbering fewer than 10 in the United States, this enigmatic being demands a dual expertise in balloon and airship operations. With no specific pilot certificate, these treasures defy easy classification, their intricacies beyond the scope of our present Odyssey. As we conclude our exploration, let the curtain fall on this balletic revelation. The hot air balloon, with its ensemble of components, whispers tales of fire-kissed ascents, guided descents, and the eternal dance with the winds, a symphony of flight that transcends the earthly realm. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.